Galvanometer. Galvanometer is the instrument to detect the current and the direction of current. Galvanometer cannot measure the current, cannot measure the voltage, but it measures only the presence of current in the circuit and direction of the current. If direction is in this direction, then the needle will be towards right. If the current is in opposite direction, the needle will be here. If current is not passing, then it will show the zero. So there are deflection. If it is towards right, means current is moving in this direction. If it is towards the left, it is moving in this direction. So galvanometer indicates the current as well as its direction. It cannot measure the magnitude of the current. The current required for the deflection is very small for the galvanometer. Now, galvanometer can be converted into ammeter and voltmeter. So, how to convert a galvanometer into ammeter? What is the ideal ammeter? What is the ideal voltmeter? So, ideal ammeter has zero resistance. So, it is not possible to construct an ideal ammeter with the help of galvanometer, because if the current is zero, then there will be no deflection. Hence, it cannot be converted into ammeter correctly. Now, ideal voltmeter, the resistance is infinite. If the resistance is infinite, then what will be the current? Current will be equal to zero. So, there will be no deflection. So, in the both the cases, ideal ammeter cannot be possible, or it is the ideal ammeter is not possible, or we cannot have a ideal ammeter which is converted from the galvanometer. Similarly, we cannot have a ideal voltmeter which is converted from the galvanometer. Now, what is the use of ammeter? Ammeter is used to measure the current in the circuit. So, ammeter is always connected in series with the circuit. If the resistance is more, if resistance is zero, then it will not change the current. But it is not possible to have the zero resistance. So, the resistance of ammeter should be negligible so that it doesn't change the current of the circuit. The ideal voltmeter is used to measure the EMF or the potential difference between the two circuits. So, the voltmeter is converted to parallel to the battery to find EMF, or at the two terminals of the resistance where we will find the potential difference. So, if the resistance, ideal resistance is infinite, then what will there? There will be no current. So, there will be no deflection. So, ideal voltmeter is not possible. Ideal ammeter is not possible. Ammeter is always connected in series and voltmeter is always connected in parallel. If we put the voltmeter in series, what will happen? If we put the voltmeter in the series, then its resistance is very high. So, it will change the current drastically. So, large amount of the current will be changed. So, voltmeter cannot be used in series. Similarly, ideal ammeter should be used in series, because the current in the circuit should pass through the ammeter completely. Now, how to convert a galvanometer into ammeter? Suppose this is our galvanometer and we want to convert to measure the current from 0 to 1 ampere or 0 to I. I may be 5 ampere, 10 ampere, milliampere, microampere. We can choose any value of the current to measure by the galvanometer. Ij is current for full scale deflection. If Ij current is passed through the galvanometer, it will show the maximum deflection. G is the resistance of the galvanometer. Capital G is the resistance. Where is the resistance of galvanometer? The resistance of galvanometer is the resistance of the coil. This resistance of the galvanometer is not connected in series or it is not connected in parallel, but it is the resistance of the coil. So the capital J is neither connected in series with the galvanometer nor connected parallel to the galvanometer, but it is the resistance of the coil of the galvanometer. Now suppose this is the circuit and I current is passing through it. So we want to measure the current I, it is passing through it. Then through galvanometer, when I current is there, there is the range. So at this point there will be maximum current or the deflection should be maximum, and so the current Ig will pass through the galvanometer. Then rest of current I minus Ig will pass through the sun, and this is the small resistance connected in parallel to it. Again here I plus Ig and Ij, I will be there. So how to find the value of S? Now at this point A and B, the potential difference will be equal to I minus Ig into S. Similarly, we can find the potential difference AB will be equal to Ig into galvanometer resistance. So VAB will be equal to I minus Ig into S. This is equal to Ig into G. Ig into G, it is potential difference between A and B. Similarly, I minus Ig into S, that is also potential difference between. So we will connect it. So S will be equal to, divide it. So it will be Ig into G, but I minus Ig. So the value of Ig is fixed for the galvanometer. Ig for a given galvanometer is constant. The resistance of the galvanometer is also constant. So S will depend upon I, means the range from 0 to I. Suppose it is I is equal to 2, then we will put it 2 ampere. I is microampere, then we will put it microampere here. So S can be calculated by this formula, and we have the resistance of that resistance which is calculated here. Then this galvanometer will work as a ammeter which can measure from 0 to I ampere current. Now what will be the effective resistance of the galvanometer? Now galvanometer is a parallel combination of resistance of galvanometer and shunt resistance. So it is a parallel combination of S and G. So the resistance will be, they are in parallel. So the effective resistance will be equal to S into G divided by S plus G. So since G is much higher than S, therefore the value of effective resistance is less than S. Convert a galvanometer into a voltmeter. Now voltmeter is a device to measure EMF or potential difference. So we will use it parallel to the circuit where we want to find the EMF or potential difference. Now suppose we have to find the high resistance which is connected in series with the galvanometer so that it is converted to voltmeter. Now the range for which you will convert the galvanometer is suppose 0 to 4. Now if I current is passing through it, then for the full scale deflection, when it will show the V voltage, then the deflection should be maximum. And for maximum deflection, the current required for the galvanometer is Ig. So Ig current will pass through the galvanometer, then there will deflection will be equal to V volt. So here the resistance of galvanometer is G. Rs is the series resistance, or which is high resistance connected in series, and the potential difference between these two terminals, terminal A and B, is V. So V will be equal to potential difference, V will be equal to Ig multiplied by G plus Rs. So total resistance will be equal to G plus Rs multiplied by, this will be the volt. So V will be equal to Rs, which is the series resistance, plus G, the resistance of galvanometer, times Ig. So Rs will be equal to V divided by Ig minus G. So the resistance which is to be converted is required to convert the galvanometer into voltmeter. The series resistance will be equal to V divided by Ig minus G. As I have told earlier, Ig is constant for a given voltmeter. Okay, sorry, for the given galvanometer. G is the resistance of galvanometer. That is also fixed. Both things are there. So Rs will depend upon the range. If it is 5 volt, then Rs will be less. If V is 10 volt, then Rs will be more. So Rs will depend upon the maximum voltage which we want to measure it. So we will, here Rs will be it is a much larger than G. The value of G is always less than 100 ohm, and Rs is always more than 1000 ohm, nearly 1000 ohm, or even more than this. It will depend upon the field. What will be the effective resistance? Effective resistance will be the G plus Rs, because they are in series. So the effective resistance of the voltmeter will be equal to Rs plus G. Now both the experiments to convert a voltmeter and to convert a ammeter from the galvanometer is in your practical. So we have to first find the galvanometer resistance and Ig, that is the current for the full scale deflection, we have to find. So we will have a circuit like this. This is a battery. The EMF of battery is suppose capital E, then key, then here is a high resistance box which the value we can change, and we convert the galvanometer in series. So the circuit is completed, and we have a resistance here, resistance box. This resistance is low resistance box. This is low resistance box. Means its resistance is 0 to 100 ohm. Here high resistance was 0 to 10,000 ohm. So that is the high resistance, and this is the low resistance. It is connected in parallel with the key. Now first what we'll do, we will have K1 is open, then we will adjust the resistance and we will find the number of division in the galvanometer. Suppose it is small n is the number, then what we'll do, we will close the key K1 and change the resistance so that deflection is n by 2. What do you mean by this? Formally, suppose the deflection was 26 division. Now when we hear a resistance change, and resistance is such that it is 13 division. So the 50% current passes through this, 50% passes through this. It means the resistance of galvanometer is equal to the resistance which is parallel to it. So 50% current will pass here. So this resistance will be the resistance of the galvanometer. So in this way we can find the resistance of the galvanometer. So we will take the number of the observation, we change R and have the deflection. We should always have a deflection in even number. Now close the key and find the resistance where the deflection is half. That resistance will be the resistance of the galvanometer. So you have to take the 5 to 6 readings and the resistance of the galvanometer is fixed. So this R will be fixed. Simply you change the resistance, get the deflection, close the key and have the 50% deflection. So अपन क्या करेंगे कि रेजिस्टेंस हाई रेजिस्टेंस को तो चेंज करके इसमें डिफ्लेक्शन ले लेंगे. सपोज डिफ्लेक्शन जो है वह 28 है, देन वी क्लोज इट, इसको क्लोज कर देंगे और आर को चेंज करेंगे कि ये जो है वह 14 हो जाए. तो ये रेजिस्टेंस गैल्वेनोमीटर के रेजिस्टेंस के बराबर होगा. दिस इज वन ऑफ द एग्जाम experiment in your practical. Now second we have to find the Ig. How to find the Ig? Now we know the resistance, here we know the deflection. So if the EMF of battery, we measure it with the voltmeter and EMF of the battery is E, RH resistance was this. In the resistance box, the number of division N, in the deflection, capital N is the total number of division. Suppose it is a 50 then 50, 30 then 30. So maximum division is capital N. Then we will calculate it. The Ig will be equal to capital E divided by RH plus RG. This is the total resistance of the circuit. So ये कह देगा total current of the circuit multiplied by N, total number of division divided by small n. So we will take 5 to 6 reading and we will calculate the value of Ig. So Ig should be calculated and it should be a correct one. If Ig is not correct, then for the conversion in the voltmeter Ig is required. For the conversion in ammeter Ig is required. So you should take sufficient accuracy to measure Ig. So Ig measure करने के लिए हमें क्या करना है? R H की वैल्यू रखिए, ऐसा रखिए कि जिसमें इसके अंदर जो है वह डिवीजन जो है वह इवन नंबर आए. तो ये इवन नंबर n आ गया. फिर आपका RH की वैल्यू आ गई. E बैटरी का नाप किया आपने, R H और G को ऐड कर दिया. G अपने निकाल दिया गैल्वेनोमीटर का और कैपिटल N और N का Ig का. तो Ig की वैल्यू अपन निकाल लेंगे. Ig की वैल्यू मान अपन को ज्ञात होने के बाद में हम आसानी से इस गैल्वेनोमीटर को वोल्ट मीटर में बदल सकते हैं, एमीटर में बदल सकते हैं. फॉर्मूले को यूज लेकर के शंट की वैल्यू और द हाई रेजिस्टेंस की वैल्यू अपन कैलकुलेट करके निकाल सकते हैं. तो ये जो है वह 3 एक्सपेरिमेंट आपके जो है वह लेबोरेटरी में है. और 3 एक्सपेरिमेंट गैल्वेनोमीटर का रेजिस्टेंस निकालना, Ig निकालना, देन कन्वर्ट टू एमीटर, कन्वर्ट टू वोल्टमीटर एंड देयर कैलिब्रेशन आपको करने हैं. एक्सरसाइज. नाउ वी हैव टू, इट इज गिवन दैट Ig, the current for full scale difference is 10 milliampere, that is 10 into 10 raised to minus 3, that is equal to 10 raised to minus 2 ampere. The resistance of the galvanometer is 100 ohm. Now we have to find the shunt to convert it to ammeter whose range is 0 to 5 ampere. Now we have to find the high resistance series to convert it from 0 to 10 volt. Now we will find the effective value of the resistance of ammeter and effective value of the resistance of the voltmeter. So first we will find the shunt for the ammeter. Shunt for the RS, shunt for the resistance is Ig into G bata I minus Ig. Now I 5 maximum 0 to 5 ampere, so I is equal to 5 ampere. So we substitute the value. Ig is 10 raised to minus 2 into G is 100 divided by I is 5 ampere minus 10 raised to minus. This is equal to, this will be 100. This will be 1 divided by 4 minus 0.01, that is equal to 4.99, that is equal to 0.2 ohm. So the resistance will be 0.2 ohm for the conversion of this galvanometer into ammeter, which can have the range from 0 to 5 ampere. Now we have to find for the conversion of voltmeter, we will find the high resistance. Now high resistance for the voltmeter RH is equal to V bata Ig minus G. V is equal to 10 volt. We will convert it from 0 to 10 volt. So V is 10, Ig is 10 raised to minus 2 minus G. So RH will be equal to, this will be 1000 minus 100, so 900 ohm. So 900 ohm will be connected in series to convert this galvanometer into voltmeter. And here we will take a 0.2 ohm resistance parallel to the galvanometer, so that it is converted to a ammeter which can have or which can detect the current from 0 to 5 ampere. Effective resistance for the ammeter. Effective resistance for the ammeter will be equal to parallel combination of S and G. So it will be S into G divided by R S plus S, G plus S. G plus S. We substitute the value. S is 0.2 multiplied by 100, 0.2 plus 100, so it is 20 divided by 100.2, so this is equal to 0.1992 ohm. The effective resistance of voltmeter is, now the galvanometer and resistance are in series, so effective resistance will be equal to high resistance plus galvanometer resistance. High resistance is 900, galvanometer is 100, so it is equal to 1000 ohm in resistance. Now we will take the next example exercise, which is based on the cyclotron. In the cyclotron, we want to accelerate deuteron. Deuteron is 1h2. So the mass of deuteron is equal to the 2 protons. So, sorry, 2h1. 2h1. Neutron is 2h1. So mass is equal to 2 mass of the proton, 2 into 1.6 into 10 raised to power minus 27 kilogram. The charge is 1, so it is equal to 1.6 into 10 raised to power minus 19. Now, if the magnetic field V is 1.5 Tesla, then we have to find the frequency of oscillator which is required for the cyclotron. If the maximum, second is, if the maximum energy is 15 MeV, then we have to find the number of total revolutions of the deuteron if the potential difference between the 2D is 50 kilovolt. So the frequency of the oscillator, as we have discussed earlier, the frequency will be equal to Q into P divided by 2 pi into M. Q is equal to 1.6 10 raised to minus 19. B is 1.5 Tesla divided by 2 into pi is 3.14 into mass is equal to 2 into 2 into 1.67 into 10 raised to minus 27. We will solve it and we will find the value of the frequency, and it can be calculated easily. Now, second part is, if the energy of the neutron is required is 15 MeV. So, total energy E maximum is 15 MeV, 15 into 10 into 6 electron volt. Now, energy gain in one cycle is equal to 2 into V into Q. Q is the charge of the particle and V is the potential difference between the two D's, so 2dQ. So, the number of oscillations will be equal to total energy divided by the gain in energy in one cycle or in one revolution. So, energy is 15 into 10 into 6 electron volt divided by 2 into V is equal to 50 into 10 into 3 kilovolt. So, it will be equal to 150. So, the neutron after 150 revolution will get the energy which is equal to 15 MeV energy.